So, thanks for your patience. So, few things. Yesterday, Jona gave a talk on Docker, right? So, what is Docker about? Because I wasn't here, so how would I know? Let's do a quality assessment. What's Docker? If you ask me who is Docker, then we're in trouble. So, but let's stick to the what. Anyone? Okay.
So like you set up operating system remotely, and you can build like set a server on it and applications on it. Like
Yeah. So it's what you described sounds a bit like a virtual machine, right?
Yes.
Is it the same or is it different?
It's different.
Why? It's an open question. Anyone is. I don't want to put you on the spot. Don't feel like this. Fine. Yeah. So what's the purpose of containers? Why do we use containers, not virtual machines? I mean, it sounds. I don't know. To me, it sounds like the same right now. Please.
They're easier to scale, so you can deploy more if you need more.
That's right. What does scale mean in this context?
So if more users log or use the servers at the same time, you can deploy more, so you have more capacity.
Yeah, yeah, that's right. So it's flexible. You can create multiple without much interference, right? So it's kind of made for that, as opposed to you figuring out, okay, which IP address can I use now because you don't have a conflict and things like this. So it's done for this. I'm not sure who was first. Oh, it's behind me, heaps of them, please.
The Docker container has runs on no extra operating system, so it runs directly on the base.
Yeah.
So there's no hypervisor.
But what is the benefit of that?
That means you get increased speed
Yeah.
and more lightweight.
Yeah.
Yeah.
Yeah. You want to add to this?
Not directly to that, I suppose. But,
Okay. Please.
Wasn't so the initial point of it was that it was difficult to develop for deployment, as the libraries and such on the operating system might not be the same that you have, or if you're developing on Mac and the server is Linux, it gets complicated that way. So you can package all the libraries that you need for that program in Docker in the container.
Yeah. So there's multiple points here. So on the one hand, there's the efficiency aspect. By directly moving from, I'll probably borrow from Jonas' slide set here. By directly moving from the operating system to the Docker engine, you get rid of the abstractions. So it was one point was made. So you don't have a fully fledged operating system with its own user management, process management, networking, and so on that sits within another operating system, which is kind of confusing because you kind of replicate something you have already in hardware in software, so which is of course very expensive. So it's a matter of abstraction. The second one was easy, scalability. So basically multiplicity. The assumption is no longer that you run one virtual machine on a given host, or perhaps 2 or 5, but can run 50 if you want to, right? And it should be really easy to scale them up and down. And then there's the third aspect. Well, if you had lived before the 2010 era, it was like if you go to a Git repository, what do you usually find? Code, yeah, exactly, code, right? Literally, code, right? And you need to guess, okay, if you're lucky, you get a README. But in any case, it won't then generally help you much in getting it running. You still need to debug your way around, figure out, okay, what was that actual development environment the person most likely used? What is the target environment that is to be expected? Oh, this version of a library doesn't work. And it didn't mention that it's actually Python 2 that it requires as opposed to Python 3, which any sane person would use. So those kind of things were a bit of a trouble. In fact, you had even worse situations. I talked to someone from Canonical at that time, and his point was, well, it's really hard to actually install 2 competing applications at the same time if one of them uses Python 2 and one of them Python 3, or a particular version of Python 2, because you can't easily maintain them at the same time on a given operating system. So meaning one of the points is also to isolate. So you have a given runtime environment for the software actually downloading, which is isolated from another one. So the idea is there, if you have multiple Docker containers, which first of all break the idea of abstraction from the underlying operating system, you also package only the needed libraries alongside the application that you actually want to deploy, right? So that's the key idea there. So you don't waste 2 days in just getting something running before you can assess whether it's useful or not to you in the first place, right? Classical challenge we have. If you're lucky, you would find something like a bash script or something, but even that one wouldn't necessarily solve all the problems they have. In fact, it may just make it to some extent worse. And the idea is there that Docker really provides like a kind of standardized interface. Now looking at this the deployment perspective, but looking from a developer perspective, it also provides a sort of standardized interface of how to describe the runtime configuration of your code, right? So the idea is ideally there, if you package your file and you provide a Docker file, well, anyone will know how to run this thing. Right? So there's no discussions anymore. There's no which libraries do I need, which particular issues do I need. Sure, you may have issues with the Docker version and so on, right? That you have certain features that you require that an older Docker version that is packaged with Ubuntu, for example, doesn't have, and so on. Those are, I think, problems of immaturity of the system. But fundamentally, the idea is you have kind of a new abstraction language. So if you enter any DevOps person or your co-developers or sysadmin or I don't know whom, hand over a Docker file, the person should in principle be able to run it with the fundamental knowledge of some commands that are involved, right? So those are the 3 points that I think worthwhile, right? Breaking abstraction, multiplicity, and standardization of execution, right? So those there was another point?
What is the Docker engine? What is, like, I know that the Docker
Right.
runs in Docker, but what is
So, yeah, so the Docker engine is basically the runtime environment for Docker containers. What is that? Well, the Docker engine provides you with a set of useful features. One of them is, first of all, it performs the mapping, for example, of processes on the host operating system. So if you, for example, running Linux, right, you know that process IDs are generally unique, right? You always have those usual 4-digit numbers that are your process IDs that you manage. Well, one of the challenges or one of the features that the Docker engine does, for example, is to translate between an internal representation of your process IDs that is valid for your Docker containers and, for example, the external one, so doing this kind of mapping. Second aspect is it allows you to have access, for example, to networking capabilities mediated via the operating system, but it also involves setting up an internal network, so you have actually communicating amongst the individual Docker containers, right? The deployed instances as well. So that's basically the management environment that exists to allow you to actually, it's kind of the infrastructure for the Docker containers basically, right? Including networking, CPU allocations, and those are the main things actually. The other thing it facilitates, you can map between operating system, level file system and Docker file system as well. This is generally not exercised much because it breaks the idea of having some sort of abstraction between the runtime system. If you assume that you access a particular location on the local operating system, but you can nevertheless do that, of course, right? So those are features that are also facilitated by the Docker engine. So it's basically fundamentally responsible for spinning up, spinning down those machines, ensuring they run next to each other, dealing with conflict-free resource allocation, especially with respect to networking, but also the process IDs. Those are the main features I think worthwhile highlighting here. Of course, it is the hook point for any further features. So Jone yesterday talked about Docker containers, so web server, database servers. There's also a different concept called volumes, which have you touched volumes? No, right? No. So volumes is a secondary element there. It's only about state maintenance. So think about it like hard drives that you plug in to your Docker container, Docker engine as well, and then you can use them individually or across different Docker containers as well. That's the easiest way of sharing data, for example. Let's assume you have a Docker container that multiple Docker containers that need to access the same data, right? So you have perhaps non-changing data even, but you don't want to replicate them, but you want to make them easily accessible. Well, you put them in a volume, give all instances of Docker access to that volume so they can directly work on the same data as opposed to replicating the data, which sometimes simply doesn't make sense. If you think about applications there, generally, I mean, in software Systementwicklung, I guess, I'm not sure, I'm being a bit on a limb here. I think you probably talked about multi-tier systems in terms of structure, right? So you have more like the user-facing UI-centric structure element, then you have the logic-centric elements, and then you have the data-centric backend element, right? And depending what you want to Dockerize, it may make sense to have multiple instances running that can be low-key. For example, logic is usually quite easy to Dockerize or parallelize, because you just run the same thing across different machines, but on the same data. What is hard to replicate is data, right? Ensuring consistency on a given database, let's assume insurance database, while running multiple Docker containers is quite a bit challenging, because you need to ensure at the end the data are all consistent, right? So that the next request works on the latest snapshot of the data. Whereas again, in the case of logic or user-facing applications, that's not so much a problem, meaning UI representations and the like. So those are some of the main points there. So Jonas showed you how to run containers. That's the key idea. So you have a basic understanding of how to run them. I'll just want to make a few. Are there any questions regarding containers further, or Docker? I have some more comments, but as far as the understanding goes, because that's the understanding I want you to get away with, that we just have developed. Yeah, please.
What application do you use Docker?
Good one. So I'm.
I
I see. So generally, yeah, that's right. I mean, generally, of course, it's server-side applications, right? So you Dockerize something on the server. It's not like you're downloading. Here's your client instruction. Please download Docker and run this. People do this. I call them the nerds, because you can really do good stuff with this. For example, you can Dockerize your IDE, right? You have an IDE with a lot of plugins on. You can Dockerize this thing and basically run it on your local machine. People do that. Yes, I know they do. It's weird. But that's not the point. The point is running on the back end, right? It's really about easy deployment. So if I tell you, please run my application, now it should be relatively easy, right? So if you have a Docker file, I just type Docker run and then follow your instructions, literally your command line effectively, that you provide me in the ideal case, to run. But I think in terms of server-side applications, I don't see any particular limitations of not using Docker in the first place for deployment, unless you can point some examples out where you think it's not useful to think Docker, use Docker. I think for any possible pathway. So you can have, for example, databases. Of course, you can Dockerize, because then you can separate the database management engine from the actual data, nicely separated in volumes. So very convenient. Logic is quite useful for Dockerization because of the scalability aspect. Classic example, web shop. So the reason, of course, why we use Docker is that you expose something generally to the internet, or to load in the best case. So if you run it within a company, there's still value of Dockerizing, but often it's not the scalability aspect. But when it comes to scalability, a classic example are web shops during the Christmas season. Guess what happens?
People buy lots of stuff.
Exactly, right? So the demand will increase by magnitudes, right? So it's really suddenly you have peak demands of factor 5 to 10 that you would compared to what you normally have throughout the year. You need to accommodate this. So it's very easy then to spin yet another Docker container that interacts with the user, calculates prices and all that kind of jazz, as opposed to having a sufficiently crunchy machine plus network connection that allows you to run this all on one or more machines in some sort of simple cluster, basically. But with Docker, it's then really easy to rent computing facilities, for example, with Amazon, Azure, or Google, and basically redirect all the traffic there. But they fundamentally execute your application, because all those three vendors, or more than those, I'm just highlighting the big three ones, they provide dedicated container services. They are all different names. What I call with AWS, I think container service just generally, but fundamentally what they do is, please give me a Docker file and the associated code, and I'll run this for you, and then you provide rules by which you can scale up or down the number of containers. For example, if the processor load for the existing containers is over 50% for more than 30 seconds, spin up yet another one. Right? And that goes on until you manage, for example, the processor load, right? And if you have, for example, a load of less than 10% for 2 minutes, spin down an additional container, right? So this way, basically on rules, you can perform this kind of load balancing approach where you spin up or down containers. So it's primarily geared for those internet-facing applications, but in principle, I would go as far as me as a former sysadmin, I feel like it's a really nice lingua franca for interacting between the developer side and the system administration side, right? Because if you have a Docker a file or Docker Compose file, some few words on this later, then you kind of know both where you are. The developer knows what the or can specify what needs to be run, and also can test it in a realistic condition. Basically, you develop something on your local machine, then Dockerize it, see does it run in Docker. It's a good quality assessment in the first place. And of course, the DevOps or Drift person in the widest sense will immediately know what to do. If you see a Docker file in your repo, you kind of don't need much instructions anymore. Well, perhaps you need, in terms of path mapping and so on, but it makes life a lot easier. So there's this communication thing going on between those different parties as well. But can anyone think about an application where Docker is not suitable or useful?
Game servers.
Yeah, why? Or possibly why?
Because of the overhead.
Yeah, that's right. So that's a very good point actually you're making. So any application that is efficiency oriented, you kind of need to place your bets well, right? If you have a constant load and you require high efficiency, it may be better to just run it natively. But if you have high load and you require scalability, meaning variation in use, perhaps Docker may still be the better option. Just having a bit more crunchier VM on the, below it, more performance below it, then it actually kind of could make sense. The other case where Docker is against all expectations, yes, Docker is faster than starting Docker is faster than starting a virtual machine. But starting Docker container is not fast either, right? It always takes a few milliseconds, so it's not super instant in that sense. So if you want to scale up and down, you do that with a certain sort of tolerance, right? So that's why I mentioned you wait at least 30 seconds or 2 minutes or something before you do anything. You don't do it in a very immediate real-time fashion, right? So because that will also introduce, first of all, latency and requires a reconfiguration of the infrastructure. If you really need to be very efficient, you could be better off just doing it custom and really building it from scratch completely yourself. So in game servers areas, that may be a possible pathway. Yep. Other applications that you could come up with intuitively? Well, in practice, I think there's little reason not to Dockerize. I think it should slowly become best practice to have a Docker file in your repository if you run something, especially of course it's server side. If it's client side, well, different story. Cool. But the key benefits are somewhat clear conceptually, right? So that's the main benefit. We're not pushing it far here. So NTNU offers IMT2681. That's one of the courses that is highly recommendable if you're keen in Docker, because they look really deeply into how to build up infrastructures, much more complex, using Docker as part of the infrastructure, but also explaining. I think they look at Kubernetes as well, Docker Swarm. Anyone taking that course?
Docker Swarm.
Docker Swarm. There you go. So that's the scalability thing. So right now we're just building containers, right? But we actually don't show you how to scale them up and down, right? That's sadly where this exercise will end to some extent. But Docker Swarm is the next step, where you basically say, here, those are the containers, those are the rules. Now, let's put load on it and see if they actually perform to it, right? So that's kind of a classical drift problem that you are facing. The other course that also links to it is Infrastructure as Code, also held in EE Core. But that's what the interaction is about here, that we, as developers, understand what Docker is about in order to deliver it. So one other tech that I, at this stage, don't see that we have the time to really go into it by example. I have some videos of this from past iterations, but will not require it, is the idea of Docker Compose. What is that? Not the drift people. Okay, the drift people as well. Docker Compose? Please, enlighten me.
Well, how to describe it?
Yeah, what is it about? Why do you, now we have Docker, and then now I throw another term in. Docker Compose, why do we need this suddenly?
Generally, well, you would often want to deploy several instances at the same time that rely on each other, that communicates with each other. and you can use the Docker compose file or Docker compose system type thing to define which instances that should run. And of course, when you use Docker Swarm, you will also use Docker Compose to deploy services. And you can define how many you want of each, and etc.
Yep. So I think that's a good summary providing, so you have some picture of that. But the fundamental idea here is scaling it up is of course one thing, right? Meaning looking at multiple instances of the same nature. But what about if my web application, that's your point, consists simply of multiple components in the first place, right? If you have your web server right now, that you wrote for assignment 2, your web service right now that you wrote for assignment 2, in practice there's actually 2 components in there, right? No? Who sees the 2 components or 2 sub-services you could think about in your assignment 2 service?
Database and the server.
That's right. So database, of course, most likely you use Firestore or whatever else NoSQL solution you wanted to use. But fundamentally, in an environment that you control, you probably run the database as well, right? So you would have something like MongoDB and so on. So suddenly you have 2 containers. Of course, it may seemingly make sense to say, well, let's put it all in one container. Why not, right? So because they depend on each other and everything is good, right? Why not one? Why 2?
It is technically possible, yes, but it is seen as both bad practice and it goes against the spirit of containerization, where you're supposed to run one service per container.
That's the thing. Yes, exactly. So one of the key points again is the fact that you're damaging the ability to scale, right? Because suddenly, what is if you only need more load on the web service, the web-facing element, but not on the data storage? Why crank both of them up, right? So you're ignoring the isolation of them, potentially of how it actually works. I just have some brief slide here. So how that works in practice is you have a Docker file that, like Jonas showed you yesterday, that you have this idea from which image you build, what you do, what components to add, and so on. And then you actually have a running solution. And Docker Compose looks at it from a higher level. I'm just providing here a very simple example. It's a Docker Compose file. It's in the YAML format, so it's a different representation format. But instead of getting all worried about what's happening here, I just highlight basically what this is about. So there's the version of this format that's specified, and it specifies services and volumes. So services are actual services that are running, it's generally logic-centered, and volumes is this kind of shared data concept, right, that is shared amongst those different services potentially. And the services are declared here. You see with the indentation DB and WordPress. This is of course not our example, but a random other one, but just to share the intuition of how it does things. So you basically tell the system then, well, actually for the DB, please use as image MySQL 5.7. So MySQL, well, that's the MySQL stock image as you can download it, and 5.7 is the tag, that's the version, right? So one of the challenges that if we deploy software, we developers oftentimes don't really specify the versions of the dependencies. They just say, hey, please use Python, right? But it doesn't necessarily tell you the exact version of Python. And for this purpose, images in Docker generally have the option to specify tags or versions in particular, and if none is specified, it always takes the latest one. So it's a default tag that would be used as well. So then you can basically tell it, that's the image you use, this is the volume you use. The volume is kind of reoccurring here, so that's kind of a data thing. Please use that volume. Okay, it means basically map this volume in this location in your image. So because there's a virtual file system within a container which looks as a simplified version of a Unix file system, and it says, in this particular location, please map this volume. What does it do in practice? Anyone who has seen MySQL before may see what's happening there? Well, it's the location that MySQL, you know MySQL from databases right now, right? Cool. That's the location internally on Linux that MySQL uses to store its data. Basically, the idea is to get the actual data out of the service container and put it into the volume, right? So if you spin up 2 of those things, they work on the same data, right? Only the management engine is duplicated, but not the data structure. So behind it. So that's the thing. Then there's things like options such as restart always. So what's that about? Well, if your service crashes, Docker will deal with this as well. It's another feature of the Docker daemon there. It will bluntly try to restart your Docker container. Sometimes it's clever, sometimes it's not clever. But it generally will be blindly committed. You can also be more complex and specify, hey, please only try it 5 times and then give up, or something like this, or simply shut it down. Right? So it's various options. And then you can pass things like environment variables. For example, for MySQL, of course, you need to provide some credentials. So that are default credentials, for example. Those can be passed as well. Now we can see the parallels here. This is another service called WordPress, which, as you will see easy, depends on DB, for example, right? So here's the dependency aspect that was mentioned just here before. So it's important that from this specification, the Docker Compose will derive, oh, hang on, I need to run this container first, and then this one, since this one depends on this one, right? It will resolve those dependency and start the containers appropriately. So, meaning if you have multiple containers, of course, you can start them by hand. But again, there's a lot of knowledge that you need to think about, right? In which order do I need to start them? Is there timeout between? And all that kind of stuff. And that's hopefully all managed here. So it depends on DB. What's the image? Well, use the latest WordPress you can find on Docker Hub. Get to that in a second. And finally, it does something that's called port mapping. You want to talk about port mapping, right?
Yes, a little bit.
Yeah. What's port mapping?
There's a port on the Docker, then you allocate it to a port on your local machines.
Correct.
So that's how they communicate.
Correct. So as mentioned before, there's the Docker daemon, which is an abstraction between your Docker containers and your local machine. And this is basically about mapping, right? Mapping ports. Because you only have so many ports on your local machine, but in fact, each individual Docker container can have arbitrary, could have different ports. And sometimes you may need to map, for example, from a port 8000 to a port 80 within your container, or the other way around, right? So I think that's a local port first, and then Docker port. I always forget those. Get them mixed around. Sorry.
The Docker port comes
So there you go, Docker first. So that's the internal port, and that's the host exposed port that's associated with. So it does an internal redirection there as well. Restart policy is always, and there's some properties attached to it. So this would be a classical Docker Compose file. As you will find it. So you'll not need to make this for this course, but I want you to understand the principles on what you would need to look at if you wanted to do that. So if you have multiple services that you want to bring up. Of course, for the projects, if you want to do that, of course, that can be an integral component of your project, because the projects can also go down this operations side to some extent, right? So because you did quite a bit of programming in the first 2 assignments, but now you also have the option to explore more what does it mean to deploy multiple services and so on in addition to that one. There was a question.
Can you run Docker Compose without Docker Swarm? Can you just
Yes.
use, yeah, okay.
Yes. As it boils down, yes, Docker Compose itself is, if I recall correctly, I think it's just this Python script actually in the backend. But what it fundamentally does, it parses the file, decomposes dependencies, and simply runs the Docker instantiation on each of the containers, right? Because the properties are basically there. Well, we have the ports, we have the restart policy, we know about the images, right? And we know the name of the service that you want. It would be called WordPress_1 or something like this if it's run as an instance. And this won't be DB_1. So it uses those as names for the Docker instances. But that's fundamentally what it does. So it doesn't, yep.
Docker Compose only supports up to a certain version, so version 3.3. If you want to use anything above that, you have to use Swarm on the Compose.
Yes, that's right. So it's scaling up. Swarm is the natural next step, right? So it's Docker Compose, Docker Swarm, and if you have a certain feature set, and feature set mostly, then it's no longer manageable just by parsing a script basically. But I think Docker Swarm, do you want to push it and make that part of your assignment?
What I have already done.
In this course here?
Assignment 2, yes.
I see, okay. That's boring then. Okay. So, yeah. But that's the intuition behind it. So, while you will not be dealing with Docker Compose, or don't have to if you don't want to, one thing I just want to highlight briefly is the rough structure of a Docker file. Jone mentioned that to you before. I just want to highlight there's two ways of writing Docker files that people don't really know about, but I think it's quite important to understand. So what Jona yesterday did is the right way. So you provide a Docker file. It says what's the base image you start something from. Hang on, I have a. So this is I think roughly how the structure would look like. This is the base image where you start from, right? You say from, and that usually points to an image on Docker Hub. Docker Hub is this. You can just run it like GitHub for Docker images. And then you can you specify by best practice a label maintainer that says, hey, I'm the author of this Docker file, so at least you know whom to contact. Always good practice. You specify environment variables where needed, and then eventually you say which programs, which commands need to be run, right? So for example, if you wanted to run get update or something like this, that's how you do it. You basically prefix it with run. You copy potential variables from your into the Docker, into the newly created image, for example, from your file system. So if you have your Docker file located within your repository and you want to copy certain files, you can use copy as a particular instruction for this purpose. You can change the working directory and say, if you start something inside the Docker container, use this as a working directory. You can expose ports. You can say, please, I'm exposing in this part of this service port 8080. However, this expose is kind of not mandatory, but it's largely of documentary nature. So if your service nevertheless exposes something on port 8080, you can still access it even if expose is not specified. But it's best practice to put it there so everyone sees, because that's the part of the idea of Docker file as well, to be a kind of form of documentation of what you would need to do if you were to run it manually, which also means you should expect that there's something listening on port 8080, for example. And then there are, of course, the entry points and the command instruction that allow you to say, okay, this is the main executable, run this at the end, or when you instantiate this particular container, right? So that's all the preparatory stuff, and that's what is run at the end. That's the key idea there. So that's the core structure. I think you only discussed this, right?
The core structure of the Docker file?
Yeah.
Yeah.
Yeah. So, so one thing I want to point you at is some best practices, because Docker files are actually relatively straightforward to write. What is important, however, is that you would want to follow some best practices that are important. One of the ideas is that Docker files should be short-lived in principle. So don't make them, containers should be short-lived. So don't make the instruction extensively long. That should not be overly complex, but rather small packages of individualized atomic services, right? Separating the services and minimizing instruction where possible, not avoiding unnecessary packages. So some people may do overkill and just put all packages in. So I know my service worked. If I put all those packages in, I don't want to take individual one outs to figure out when it breaks, right? So that kind of approach. Docker files are meant to be clean. They are kind of a lowest common denominator of necessary resources, not the full feature set, right? They're minimal, because again, this would violate the first rule, which is about maintaining a short-lived and very reasonably quick to instantiate container. So one concern. Always favor build over commit. I get to that in a second. And then, of course, the best practice for Docker files, provide, if you have the from principle, right? So you say from Ubuntu, basically build my Docker file from an Ubuntu image, always specify the tags, the versions. Why is that important? I said it before, but, you know. Right.
You can break your system by just having not built the latest version, and then your user downloads the Docker file and builds a more recent version of the OS, and your libraries aren't correct.
Exactly. So that's the thing. The Docker file should be written so as to have a fixed configuration, right? And that is not time dependent. If you don't use this tag, you just say Ubuntu, or you say Ubuntu latest, which is identical effective de facto, you don't have a snapshot in time anymore. You're always working on this latest version of the particular image. So basically, your Docker file is kind of a moving target. Something may change in the Docker file without you doing anything. And that's the worst possible case for a configuration file you possibly have. So it should always indicate the version you have been using it. Even if it's outdated, then, well, you need to go ahead, test it with the recent version, and only then commit another update to your Docker file. So it's important, best practice. The second one is to indicate the maintainer. Who is the person to talk to? Right? So it's important. Who wrote this thing? One of the other, identify dependencies in your execution. So one of the challenges is that you may need to run individual commands. You see that a lot of, I mean, you are more than welcome, you should in fact go out there and look at the Docker documentation in the first place, but there's heaps of tutorials online on Docker, so you know, have a look at them. One of the things they often don't do is to get this right. Chaining dependency. Well, why would you need to chain those commands here this way? Why don't you run them as separate commands? For example, run apt update and apt update, sorry, and then run apt install xyz. Why do you chain them in this kind of left first execution way? It's kind of a Linux way of chaining, right? So you guys have seen that before, perhaps. But there's some comment, please.
Because you don't know how long it takes to get the updates. You could put it on sleep for 10 seconds and then upgrade, but.
All right. Okay. This is generally not the problem though, because it will if you run one command after the other, it will await the status code of the previous command.
Okay.
Or it will basically await the execution of the previous command. But what's more, the execution, not the status code. That's not correct. That's right. The execution. So, but what's another problem there? Please.
It's better for the cache. I mean, Docker caches in layers,
Yeah.
and this will become one layer, and it can cache the whole thing.
Yeah, that's very deep. Yes, that's right. So what he's referring to is when you build Docker files, actually, when you build Docker images, it's actually done in an individual step. After each command, there's a new incremental layer that is put on top of your image before composing the final image. So your image technically consists of layers. I think I have a visualization of this. Yes, that's the thing. Yeah. So there's a older visualization of this. So you have a basic container, you have the base image basically, and then you, for example, add a particular, here in the example, add Emacs or run apt update and so on, and it incrementally adds to the image. So it's an incremental change to the image. That's how it internally works. And the argument here is that if you run it one command, we only have one incremental layer in the image as opposed to two. Also valid argument, okay, but I'm looking at something else. What's another point why it's possibly important to chain them? Well, the answer is relatively straightforward. If you run a fresh image and you run an update, it's kind of the first update of the the synchronization with the repository, the latest state of the repository. For example, if you run Ubuntu 17.04, that's getting the latest state of the repository. If you wouldn't have done this, you don't have any latest state of the repository, and you will possibly not be able to find and install that corresponding package in the first place, because it may be simply not contained in the base image of 17.04. So the idea is that if this fails, please don't do this. Right? If get update fails, please don't run the next command afterwards, because they depend on each other. Right? So and if you identify those, this is the most typical case, update, I promise you, and then the associated installation of some packages. But if you recognize cases where the dependency between two commands is very tight, chain them in this way. In all other cases, just write them individually. Cool.
So the chain doesn't mean that. So they have to run in that particular order. Is that what I mean?
Yes. Yeah. So it means run the first one first, right? And once done with this one, run the second one. Yeah.
The second one only runs if the first one succeeds.
That's correct. That's correct. Best practice for arguments: if you have multiple arguments and you want to, especially if you have a lot of arguments for a particular command, sort them like by alphabet, so it's easier to find them. Because if you know that convention, you know, I'm looking for, I don't know, the link option. Then, well, you're faster at parsing it simply. That's one of the arguments there. And use expose to make Docker ports explicit. Again, it's no requirement, but it's best practice. That's why I'm putting them out here. A lot more best practices, and a lot more. This is just a selection of other ones. if you write your Docker file, I think it's sensible to just, at the end of it, just briefly go through it. Come on. Sensitivity is very high here today, so let's see. There you go. Docker file best practices is linked in the repo, and it basically gives you a lot more. I mean, quite extensive. So I'm not suggesting you read all through that stuff, but where you see it could be relevant for you, just see if there's any rules you want to learn about. But I think the ones highlighted here are the most essential ones that you want to think about. One other aspect that I wanted to highlight in terms of Docker, as I just mentioned before, there's a difference between, and hopefully you will never see one of the practices. There's a difference between building images incrementally and building them using a Docker file. So what Jon did is the right way, and it's always to be done this way. But there's another way as well of doing this. So what Jon did was basically specify a base image, maintainer, run the following command, install the following packages, apt update, put something in there, and then basically run Docker build. What the interactive thing does is basically you're pulling a base image calling Docker pull. You write into the image, so you're basically interactively modifying this thing, this container, and then you're committing it at the end. And then you have also a valid image you can use, replicate, and whatever else. What's the risk with this kind of approach? Who is scared hearing about this?
It's not repeatable.
Exactly, right? So this is one of those cases where you have this image in your organization and say, hey, I made this image, it works, build everything from there, right? And no one has a clue how the internals actually look like, because you actually started it, interactively changed something because you configured it cleverly, and no one will ever be able to retrace what you did in there, right? So this is kind of super dangerous. So if anyone points or you find any direction that goes into that hole of suggesting, oh, you can interactively install Apache on your Docker container. Sure, you can do it if you just want to do it for fun of it, or for just hacking something quickly together. But that's definitely not in any way development relevant or production ready. That's not something you would ever consider in this direction. What you get out of this is so-called kind of golden image, which is kind of magic, because everyone needs to use that image, because if you don't, everything breaks, but no one has a clue how this thing came about, who the maintainer is or was, and what this person did. Right? And that's to be avoided. Hence, always build from a Docker file. Docker files are explicit. They exactly lay out what's happening. In fact, to some extent, if somebody were to abolish Docker in 2 weeks, you can still run it by hand. That's the idea, right? So reconstruct, okay, there was something about run this command and then add this particular file. I need those environment variables and things like this, right? It's very explicit. Think about a Docker file as part of your documentation as well, right? Because that's the deployment documentation. How do I run this thing? That's answered usually by the Docker file, plus the command that you execute if there, for example, are port bindings, environment variables, and aspects like this. So I think you get a break, right? Break until until when? Break? That's generous. 8 minutes, okay. That's generous. Okay. If anyone has questions regarding project or wants to talk about the ideas, they can just come here to me and we can do it in the meantime if you want to. But of course, you have your right to break.